All right, example. A statistician is interested in estimating the IQR of the weights of NCAA football players. He develops 4 different statistics to estimate the parameter IQR. The population IQR is 80 pounds. So we don't know what statistics he used. Maybe he used sample IQR, or maybe he did some different combinations of who knows what the statistic is. Let's not overthink that, but there's just basically 4 different statistics. So which statistics are bias estimators of the population IQR? Are unbiased. Well, the true IQR is 80, so we can put a little bar here to kind of help us visualize that, right? So to find unbiased estimators, we're wondering if the mean of the sampling distribution is equal to 80. This one looks unbiased to me. It looks like the center is about 80. This one is definitely biased. This one, I would say the center is more like in here, so this one looks biased as well. Not as biased, perhaps. And this one, yeah, a couple outliers down here. Just going to pull it down, but yeah, I think this one looks unbiased to me. The question is, does it look like it would the mean of these, if you average out all these points, is it going to be equal to 80? So we're going to say it's close, so we'll just say unbiased. So I'm going to say stat 1 and 3. Which statistic has the least amount of variability? Least amount of variability, that's going to be the smallest standard deviation. This one definitely has the smallest amount of variability. So stat 2. Is it a good estimator? No, because it's biased. I'm not going to say it's a bad estimator, but we would certainly like the center of this to be at the population value so that we're not consistently underestimating the value. But it's a good estimator in fact that it's got low variability, but it's certainly just kind of overall, I would say, define what good means, right? Which statistic is the best estimator? Well, I would probably say this one. It's got a relatively low variability and it's centered right. So I would say stat 3. Why? It is unbiased. So that's good. And it has relatively low variability. Not as low variability as this one, but because it's centered right, that's probably going to be the best one, right? Excuse me. So this is just like a little bit of a thought exercise, I guess. Bias is synonymous with accuracy, and variability is synonymous with precision. I think in your science classes, you guys kind of talk about accuracy and precision. For example, this collection, if we're shooting at a target or whatever, this has these are very precise measurements. If I'm sighting in a gun or whatever, really precise measure, but it's not accurate because it's off center. So this would be high bias, but it's got low variability. It's got bad accuracy, but really good precision. So this one is centered right. It's sighted in right, so it's accurate, but it's not very precise because it's got a lot of spread. So that's low variability. High variability, low bias. This is the worst place to be. Here you're off center, so it's not accurate, and you have high variability. So, and then this is where you want to be. This is it's precise, meaning it's low variability, and it's accurate, meaning it's unbiased. So this is kind of where you want to be. So something to think about. All right, section 7.2 then is going to focus on the sampling distribution of sample proportions.